Morning, math enthusiasts. Today, we will discuss about proofs of some geometrical statements involving parallel lines. To start with, let us first discuss the principles of parallel lines. Again, we shall be using the principles and some examples of Schom's outline in geometry. In Euclidean geometry, parallel lines are straight lines which lie in the same plane and do not intersect however far they are extended. Its symbol is this. In the illustration, line segment AB do not intersect and will never intersect line segment CD. A transversal of two or more lines is a line that cuts across these lines. In the illustration, line M is a transversal that cuts across two line segments AB and CD. The interior angles formed by two lines cut by a transversal are the angles between the two lines, while the exterior angles are those outside the lines. In the illustration, the interior angles are angles 3, 4, 5, and 6. The exterior angles are angles 1, 2, 7, and 8. The corresponding angles of two lines cut by a transversal are angles on the same side of the transversal and on the same side of the lines. In the illustration, the pair of corresponding angles are angles 1 and 5, angles 2 and 6, angles 4 and 8, and angles 3 and 7. The alternate interior angles of two lines cut by a transversal are non-adjacent angles between the two lines and on opposite sides of the transversal. In the illustration, the pairs of alternate interior angles are angles 4 and 6 and 3 and 5. When parallel lines are cut by a transversal, interior angles on the same side of the transversal can be readily located by noting the capital U formed by their sides. In the illustration, the pairs of interior angles on the same side of the transversal are angles 4 and 5 and angles 3 and 6. Through a given point not on a given line, one and only one line can be drawn parallel to a given line, or the parallel line postulate. In the illustration, line segment CD is the only parallel line of line segment AB. The next principles will help us prove the two given lines are parallel. Two lines are parallel if a pair of corresponding angles are congruent. This is known as the cap theorem or the corresponding angles parallel theorem. In the illustration, since angles 1 and 2 are congruent and are corresponding angles, then by the cap theorem, we can say that line segments AB and CD are parallel. Two lines are parallel if a pair of alternate interior angles are congruent. This is known as the AIP or alternate interior parallel theorem. In the illustration, since angles 1 and 2 are congruent and are alternate interior angles, then by the AIP theorem, we can say that the line segments AB and CD are parallel. two lines are parallel if a pair of interior angles on the same side of the transversal are supplementary. In the illustration, if by addition property the sum of angles 1 and 2 is 180 degrees, which means that the angles are supplementary, then line segments AB and CD are parallel. Lines are parallel if they are perpendicular to the same line. This principle can be stated this way. Perpendiculars to the same line are parallel. In the illustration, if line segments AB and CD are both perpendicular to the transversal line M, then line segments AB and CD are parallel. Lines are parallel if they are parallel to the same line, or this principle can be restated as parallels to the same line are parallel. In the illustration, if line segments AB and CD are parallel, and line segments CD and EF are parallel, then we can say that line segments AB and EF are parallel. The next principles will help us in making consequences in our proofs when we are given parallel lines. These principles are converses of the principles aforementioned a while ago. If two lines are parallel, each pair of corresponding angles are congruent. In other words, corresponding angles of parallel lines are congruent. This principle can be called PCA corollary, or parallel corresponding angles corollary. In the illustration, since line segments AB and CD are parallel, then we can say that the corresponding angles 1 and 2 are congruent. If two lines are parallel, each pair of alternate interior angles are congruent. In other words, alternate interior angles of parallel lines are congruent. This principle is known as the PAI theorem, or parallel alternate interior theorem. In the illustration, if line segments AB and CD are parallel, then we can say that the alternate interior angles 1 and 2 are congruent. If two lines are parallel, each pair of interior angles on the same side of the transversal are supplementary. In the illustration, since line segments AB and CD are parallel, then we can say that angles 1 and 2 are supplementary angles, or their sum is 180 degrees. If lines are parallel, a line perpendicular to one of them is perpendicular to the others also. In the illustration, since line segments AB and CD are parallel, and line segment AB is perpendicular to the transversal line M, then we can say that line segment CD is also perpendicular to the transversal line M. If lines are parallel, a line parallel to one of them is parallel to the others also. In the illustration, if line segments AB and CD and EF are parallel to one another, then line segment AB is parallel to line segment CD and also to line segment EF. If the sides of two angles are respectively parallel to each other, the angles are either congruent or supplementary. In the illustration, if the sides of angles 1 and 2 are respectively parallel to each other, this one and this one, this one and this one, then angles 1 and 2 are congruent, and angles 1 and 3 are supplementary. us discuss some numerical applications of parallel lines. Example number 1 in the illustration, we need to determine the value of angles x and y given that the line segments AB and CD and EF are parallel. To do this, we simply think of the pair of angles discussed by determining which pairs of angles apply in the problem. Notice that angles x and 75 degrees are corresponding angles. We know that if two lines are parallel, then their corresponding angles are congruent, so that angle x must measure 75 degrees. To find angle y, observe that y is supplementary to 75 degrees. Thus, we subtract 75 from 180 to find y. By calculation, y is measuring 105 degrees. Example number 2. Given that the rays are parallel, find x and y. So, these rays are parallel. Then we have to determine the values of our x and our y, which are actually angles. So, we do this by identifying the pairs of angles appropriate for the problem. Observe that 2x and 3x minus 20 are alternate interior angles. Recall that if two lines are parallel, its alternate interior angles formed by a transversal are congruent. This means that we can equate 2x and 3x minus 20 because they are equal. So by transposition, or using our knowledge of linear equations, the value of x is equal to 20 degrees. That is, 3x minus 2x equals x. And transpose negative 20 to the right side of the equation, which makes it positive 20. Again, x is equal to 20 degrees. Now observe that 2x and y plus 10 are corresponding angles. So, and if these lines are parallel, its corresponding angles are congruent, so that we can equate 2x and y plus 10. And by substitution, since we already know that x is 20 degrees, so 2 times 20 is equal to y plus 10 implies that 40 is equal to y plus 10. And by transposition, then y is equal to 30 degrees. There is also another alternative in determining the value of angle y by doing vertical angles. A pair of vertical angles are always congruent in Euclidean geometry. Thus, we can say that 3x minus 20 is equal to y plus 10. And by substitution again of the value of x, the left side of the equation becomes 40 and the y is of course equal to 30 degrees. The hypothesis of the geometrical statement of example number 3 states that line segments AB and AC are congruent, and ray AE and line segment BC are parallel. The conclusion wants us to prove that ray AE bisects angle DAC. Now start with the marking of the figures as we create our plan of proof. We were given that line segments AB and AC are congruent. After marking the figure, what comes into your mind as a consequence? Correct. Angles ABC and ACB are congruent by the isosceles triangle theorem. Also, we were given that ray AE and line segment BC are parallel. We mark the lines this way to imply that these lines are parallel. Is there a consequence of this given? Yes, but it is hard to determine the consequence particularly without considering what to prove first. We need to prove that ray AE bisects angle DAC. This implies that we need first to prove that angles DAE and EAC are congruent, which is a definition of bisect. In order to prove that angles DAE and EAC are congruent, observe that corresponding angles DAE and ABC are congruent because ray AE and line segment BC are parallel. Also, alternate interior angles AEAC and angle C are congruent because ray AE and line segment BC are parallel. Recall that the base angles of ABC and angle C are congruent. Thus, by transitive property or transitivity, angles DAE and EAC are congruent. We now fill in our two-column table of proof. Statement 1 states that the first given is line segment AB congruent to line segment AC. Statement 2 is the consequence of statement 1, which states that angle ABC is congruent to angle C by the reason of the isosceles triangle theorem. Statement 3 is the second given, which states that ray AE is parallel to line segment BC. Statement 4 is the consequence of statement 3 on corresponding angles, which states that triangle ABC, 4 and 5 actually, angle ABC is congruent to angle DEE by the reason of the PCA corollary, okay, or parallel corresponding angles corollary. Statement 5 states that angle DAE is congruent to angle C by the reason of transitivity. Statement 6 is another consequence of statement 3 on alternate interior angles, which states that angle C is congruent to angle EAC by the reason of the PAI or parallel alternate interior theorem. Statement 7 states that angle DAE is congruent to angle EAC by the reason of transitivity again. Finally, the conclusion is stated in statement 8 that ray AE bisects angle DAC by the reason of the definition of an angle bisector. QED. Example number 4 wants us to prove that if the diagonals of a quadrilateral bisect each other, the opposite sides are parallel. The hypothesis of this geometrical statement is that the diagonals of a quadrilateral bisect each other, and the hypotenuse is that the opposite sides are parallel. Let us now create an illustration of the given geometrical statement. Since the hypothesis mentioned is a quadrilateral, then we draw a quadrilateral ABCD. In addition, the hypothesis mentioned about its diagonals bisecting each other. So we construct the two diagonals and consider line segments BE and ED as congruent and line segments AE and EC as congruent. The conclusion wants us to prove that the opposite sides of the quadrilateral are parallel. Quadrilateral ABCD. Alright. In our restatement, we translate the hypothesis and conclusion to mathematical symbols. Thus, the hypothesis or the given states that ABCD is a quadrilateral and that line segments AC and BD are diagonals and bisect each other. The conclusion, or what to prove, states that line segment AB is parallel to CD and line segment AD is parallel to line segment BC. Let us now do markings in our illustrations using our hypothesis. We were given that line segments AC and BD bisect each other. Thus, we mark line segments AE and EC as congruent and line segments BE and ED as congruent. Take note that we think that line segments AC and BD are not congruent, so that line segments AE and BE are not congruent. We need to prove that line segments AB and DC are parallel, as well as line segments BC and AD as parallel. To do this, we now think deductively. To prove that two lines are parallel, we need to identify a transversal and determine which angles can be congruent. To prove that line segments AB and DC are parallel, we may consider BD as a transversal. Notice that the pairs of angles that are applicable here are the alternate interior angles, namely angles ABD and angles CDB. We just need to prove one pair. Notice that each pair can be congruent if we look for two triangles containing it and proving these two triangles to be congruent. The triangles that contains this pair of alternate interior angles are triangles ABE and CDE. To prove that triangles ABE and CDE are congruent, we need three corresponding parts congruent. As you can see, only two corresponding parts were given. However, the third corresponding parts are easy to identify. Of course, you should see these vertical angles here. The vertical angles BEA and DEC are congruent by the vertical angle theorem, which states that all vertical angles are congruent. Thus, triangle ABE and CDE are congruent by the SAS postulate. Hence, by CPCTC, the alternate interior angles ABE and CDE are congruent. And so, line segments AB and DC are parallel by the AIP or alternate interior parallel theorem. The other pair of line segments also follow the same steps. Angle BEC and DEA are congruent by the vertical angle theorem, and so triangles BEC and DEA are also congruent. Thus, by CPCTC, the alternate interior angles BCE and DAE are congruent. So, line segments BC and AD are parallel by the AIP or alternate interior parallel theorem. Let us now begin with our formal proof. This is quite long. Statement 1 is what we are given and states that line segment AC and line segment BD bisect each other. Statements 2 and 3 are the consequences of statement 1. That is, line segment AE is congruent to line segment EC and line segment BE is congruent to line segment ED by the reason of the definition of bisect. Statement 4 states that angle BAA and angle DEC are vertical angles by the reason of the definition of vertical angles. Number 5, or statement number 5, is the consequence of statement 4. It states that angle BAEA is congruent to angle DEC by the reason that vertical angles are congruent. Statement 6 states that triangle BEA is congruent to triangle DEC by the reason of SAS postulate using the statements 2, 3, and 4. Statement 7 is a consequence of statement 6, which states that angle ABE is congruent to angle CDE by the reason of CPCTC or particularly CA-CTC. Statement 8 is the consequence of Statement 7, which states that line segment AB is parallel to line segment CD by the reason of AIP theorem. Notice that Statement 8 is a part of the conclusion of the geometrical statement. We need to prove the other part, and we do this by following statements 4 to 8. Statement 9 states that angle BAEC and angle DEA are vertical angles by the definition of vertical angles. Number 10, angle BEC and angle DEA are congruent because vertical angles are congruent. Statement 11 states that triangle BEC is congruent to triangle DEA by SAS postulate or following the statements 2, 3, and 8. Statement 12 is the consequence of Statement 11, which states that angle BCE is congruent to angle DAE by CPCTC or particularly CACTC. Finally, the other part of the conclusion of the geometrical statement, Statement 13, states that line segment AD is parallel to line segment BC by the AIP theorem. QED. As a recap, it is important that you recall prior principles because these principles will still be used in your proofs even if you are being acquainted with more principles. The principles in our first and second videos are important to recall in this video. It's easy to learn when one learns with enthusiasm. Bye!